Hey, you guys, this is Mr. Sal. I'm out. I had to go to a conference. I will be back on Friday, so pay attention to this lesson. There'll be some pausing in and out. It's so that you guys have some time to work on the problems. You should work on them. Try them out. See if you can do them. If you can't, you need to come back and watch the video on YouTube. Of course, I'm not there, so we will be correcting the homework, but I will not be able to take the scores. So have those set aside. You'll have some time to correct the homework, but we won't have time to correct it when I get back. So make sure your score is ready to go when I get back so that we can take those scores pretty quick and not waste too much time in class. Be good for the sub. If anyone misbehaves, please take their names down and I will deal with them when I get back. Trust me, you guys, you do not want to be on that list. If you are, not only will your parents find out about it, but you will not want to see the consequences when I get back. Trust me, they are there though. So behave yourselves, be good, take some notes, and when the lesson's over, you guys will get the homework. So try this bell workout. All right, so I'm going to use that rainbow method stuff because, well, it's fun to draw rainbows. So what we'll do first is, again, I'm just going to connect the two y values above and the two x values beneath. And to get from -5 to 0, you would have to, again, we got our fraction here, you would have to add 5. So that's our numerator, is plus 5. And to go from -6 to 4, you would have to add 10, or go to the right 10 on the number line, and that would be our denominator. And that's the nice thing about this, is everything's already in place for us to simplify the fraction. So both of these are divisible by 5 to simplify, which then gives us a final sloppage of 1/2. Well, what about number 2? Again, this is going to work the same way. So to go from 1 to 7, you'd have to add 6. That's our numerator. So plus 6 right here. And to go to from 4 to 0, you'd have to subtract 4. That's our denominator. This can be simplified. So what we'll do is we'll make a new fraction, but again, we're going to simplify these. Both these are divisible by 2, which will simplify this. 6 divided by 2 is 3. -4 divided by 2 is -2. And behold, we have our second sloppage. So notice the way the book has it written. We've got the negative right next to the 3/2. Doesn't matter where that negative is. It just depends on which direction you're going. Sometimes the 3 is negative, sometimes the 2 is negative. In any case, we can make the whole fraction negative, okay? All right, here's the homework. Going to take a moment, correct your homework. Again, you're going to keep track of the number wrong. Notice over here on number 8E, you do have to label and identify what your variables are representing. Y in this case is dollars and X is hot dogs. And here are the table and graphs. All right, Sub, thanks again for teaching my class. Take a moment now to pass out the notes, which are on the desk. All right, up to this point, you have been investigating how to describe many patterns and stories with linear relationship. You have begun to get a sense of how linear relationships are formed and described. Write down what you know about linear relationships below. So these are some things that you should have written. For example, a linear relationship is defined by its constant rate of change and its initial value. Or the constant rate of change in the graph is a linear relationship that is called sloppage, and the initial value is called the y-intercept. The equation y equals mx plus b relates to the x to y, where m is the sloppage and b is the y-intercept. Now write down what you know about linear proportional relationships. So what makes proportional relationships different? Yes, proportional relationship is a special linear relationship. A proportional relationship is defined by a proportional constant or unit rate that relates x to y. The proportional constant is the same as the unit rate in a proportional relationship. These can be interpreted as rate of change. When a proportional relationship is graphed, it is a straight line going through the origin. A proportional relation can also be represented by an equation where the proportional constant relates your x value to your y value. That is the sloppage. All right, take a moment and see if you can figure this one out. So we're going to use the facts listed above to derive the equation y equals mx using dilation. Begin by looking at the example. Now we haven't gone over dilations yet, but we will later on this year. So keep that in mind. But there's some basic things we'll have to know. Graph a line on the coordinate plane to the right that goes through the origin. So let's go ahead and give ourselves a point right now. That goes through the origin. There's a good one right there. Make that a little bit darker. That's a good color. Goes through the origin and has a sloppage of 2/3, which means that on the number line it should go up 2 and then to the right 3. And so we would have a point about right here. Label the rise and run on your graph with a right triangle. Okay. Let's connect these points first, I guess. All right, now I'm ready for that triangle stuff. So something like this. My rise is 2, my run is 3. Redraw and label this triangle in the space provided below the graph. All right, so there's a 2 by 3 triangle, or in other words, it's kind of the same triangle I drew, right? We got a rise of 2 and a run of 3. We'll get into what this triangle is right here in just a moment. So does this line describe a proportional relationship? It sure does, because this line goes through the origin and is straight. All right, now choose any point x, y on your line and draw a slope triangle that describes the rise and run. We draw and label this triangle in the space provided below on the graph. So we've done that already. As you can see, we chose this point right here, which has an unknown x value and also an unknown y value. See that right there? So that makes this point x, y. The purpose of this is just to show that it's arbitrary. It doesn't matter which point you choose. We could have chosen a point down here and it still would have been an x, y value right here. It doesn't matter if it's positive or negative. And part of that is because the slope is the same on this line no matter where you go, because it is a straight line. That is what makes it linear. And of course we've drawn this triangle down here to show the way that it is right here. Okay? So this triangle here represents some triangle that fits on this line that goes through the origin with an x value and a y value. Now we'll write a proportional statement with our ratios. So we see that we got a 90-degree angle right here. Both of these values make up our 90-degree angle. So this top part, which is called the leg, we have a 3 and an x right there, right? So in our proportional fractions, because these are ratios, fractions are ratios, we have an x value, and then on a different triangle it's a 3. Well, what about the y's? Well, this one's 2. We got 2 here and a y right here. And the 2 goes with the 3 because it's on the same triangle, and the y goes right here. Now, if we solve the equation that we just wrote above for y, all we're going to do is multiply both sides of the equation by x, like these, because then these will cancel out. Now I've got x times 2/3 equals a y, and I can switch this around, y equals, and I can also use the commutative property of multiplication to switch these to get 2/3 x. Now if you remember, that's kind of what we're going for here. We wanted to show that y equals 2/3 x on the original question for this problem. You can see it on your worksheet. Now let's look at the general case for the form y equals mx. Let's graph a line on the coordinate plane to the right that goes through the origin and has a sloppage of m. Well, if m is our sloppage, that's just the rise. We need to see some run on this thing, which would be a Juan. So a rise of m, which, I mean, we don't know what the value of m is, just maybe right here. And then one, let's say maybe right here. So it needs to go through this point, but it also needs to go through the origin. That is how we got a sloppage of m, or m over 1. All right. Now this has a slope of m. Remember that slope is the same as a unit rate, which compares your y value to an x value of 1. That's what we did. We made it m over 1. Label the rise and run on your graph with the right triangle. Okay. Well, we have a rise of m and a run of 1. Bam. Right triangle right here. We draw and label this triangle in the space provided below the graph. Well, let's go ahead and do that now. So I'd have a run of 1, a rise of m. Again, yours may not be as steep. It doesn't have to be. Let's try that line over, actually. That looks a little bit better with our right angle right here. Now notice the book did this a little bit different, right? This one is a little bit more shallow of a sloppage, but they still went up m and then to the right 1. Does this line describe a proportional relationship? It sure does. because this line is straight and it also goes through the origin. Choose any point, x, y, on your graph and draw a slope triangle that describes the rise and run. Redraw and label this triangle in the space provided below the graph. Okay. Well, as you can see, we've already chosen a point, x, y, right here. Again, if you wanted to for some reason go into quadrant 3, that would be fine as well. So, well, let's go ahead and draw that triangle as well. We've got a rise of y and a run of x. There's a right angle, and these are connected by this line. Now write a proportional statement with your ratios. So see how the y and the m they're on the same line, but they're part of different triangles. Okay, so we already know that these are proportional, which means we should have two fractions that are equivalent. And in one, we have a rise of m, and the other one has a rise of y. Well, what about the run? This one has a run of x, so that goes with the y, because it's part of the same triangle with the y. And then this has a run of 1, which is on the triangle with the m. Bam, we have a proportion. Now solve the equation that you wrote above for y. So this one will work exactly the same way that the last one did. We're going to multiply both sides of this equation by x so that these x's will cancel. Now I've got a y equals x times m. Yeah, we had it over 1, but we're going to make that a phantom one now. Well, I can switch this up and make it y equals, and then I can use the commutative property to switch these, right? Well, that gives me m times x. And again, if you look on your worksheet, that is the equation that we were looking for, meaning that this is the general equation for any line that is straight and goes through the origin. Once we find the sloppage or the rate of change, we can replace this sloppage m in the equation, and we would have the equation. All right, so let's show that the equation for a line that goes through the origin and has a sloppage of 2/5 is y equals 2/5 x. Well, yeah, some of you guys are like, well, we know it's y equals mx. Nah. And now that we know the sloppage, we can just replace that with the m and make this 2/5. No, that's not what it's saying. It's saying that we need to use dilations and proportionality. You completely missed that part, probably because I didn't read it. All right, so this line, again, it's going to be proportional. And we're going to make it go up 2 and then to the right 5, 3, 4, 5, and about right here. And then we can draw our line right here. Now we'll give ourselves a nice right triangle with this right angle right here with a rise of 2 and a run of 5. Now again, I can choose any point on this line. I'll choose this one, which is just some x, y value. So over here, this is an x, and then up here shows the y. Well, if I make this a right triangle, right here, by dilations, which is what this is, those two triangles are going to be congruent, which means they are going to have equivalent ratios. So I've got two fractions, and for the first triangle I have a rise of 2 and a run of 5. The second triangle has a rise of y and a run of x. So again, to solve this equation, I would multiply this by x, and this one may save us a little bit of time, but I'm going to multiply x by right here. And then this would cancel out the x's, and I've got y equals 2/5 x. If I switch it around, then I get this. All right, take a moment and try this one. The number of vehicles a dealership sells varies directly with the money spent on advertising. How many vehicles does the dealership sell for $1,000 spent on advertising? All right, let's take a moment and figure this one out. Again, if we can find the sloppage, then we should be able to figure out how much on one, which would be right here, $1,000.